This thing, okay. Fresh out of bed with new. I need to eat my breakfast, so with a new idea. I'm gonna eat apple juice for breakfast. Let's write a class called NiceDelta. Hey Max. Min and Max is here. Increment. No, we just go to the next. Montesa value. Oh, you still have to store those, of course. So rather allow the Montesa values. It's kind of stupid that the modulo in C++ can become negative. But I can just add, instead of subtracting 1, you can just add number of Montesa values minus 1. If Montesa equals 0 is no longer what we want. No, if it is equal to number of Montesa values minus 1. So if Montesa value is 0, yeah, then we add this. And then modulo that is still that, so then it's still that. So if it is equal to this, then it was 0. Could turn that around, I guess. But yeah, this way it's more symmetrical with that one. Could put these two lines above this and then just test on 0. I'm gonna do that because it's still 1 nanosecond faster, I think, or something like that. Just stupid that you have to add this in, I think. But yeah, turn that around as well then. So minus 1, and then we add that just because. Otherwise it could become negative. Okay. I had brilliant ideas in my mind when I woke up, but they start to fade away. What was next? Oh yeah, I stored min and max now. So I need a way to convert this to the double value that these two now represent. And before I had an operator double, but let's just give it the name value maybe. So 10 to the power exponent multiplied with this int here at the current Montesa index. So this is 1, 2 or 5 times some power of 10 as it should be. And yeah, I could make it a const expression, but I don't think I'm gonna use that like it. Let's see. Just add an m here, which returns m, papa. Well, that's nothing to do with the range size. I suppose I should use the range object here. And pass that as well as a range. Yeah, this is still outside my project even, this file. Don't have a range. Yeah, that was the definition of M. And then I might as well finish it all in one class by adding the algorithm here. So we need an initialization value. For mantissa and exponent. We can begin with the exponent. That would be simply the standard log 10. Of the range size. I'll type it in full. Where the range size is defined as max divided by min. And then you have to divide the range size by something. So the limits were like 5 and 9 or something like that. Because which one? I think I should just try to make the initial value small as as large as possible, so the m value gets as small as possible. Or maybe you should just brute force find which division here works best. Haha. Yeah, actually not a bad idea. Okay, I think I want to try to start with an m that is small enough, which means that this one must be large enough, and I'm going to try dividing by 5. And then the mantissa that belongs to that I have to pre-calculate it. let's call this the ideal delta still. Well, it's far from the ideal delta, but it comes close to what I used to call it. Actually going to increment, I think, the current object. Yeah, maybe not. So we're making the delta small, m becomes large. No, actually we'll make it large, because it divides only by 5. So m becomes small, and I want to become small enough, so the ideal delta must be large enough. So maybe I should round up. And this rounds down, which is maybe not ideal. But if then I increment it, so let's say we find the largest nice delta that is less than this one, and then I increment it one more time. Then we have the first nice delta that is larger than the ideal delta. So then we definitely have a large enough delta to get this small enough m. Which means that with this rounding down and using 0, we get a very small number. And then I can just increment it until the result is larger than the ideal delta. So it is while the current value is less than the ideal delta increment. And the current value is then given by value. Yes, I'm gonna test this quickly, as in only test the constructor. We are only dealing with positive numbers, I think. Well, max must be larger than min. So the range size is positive, so ideal delta is positive. Otherwise I couldn't even take the log 10. So I think that the constructor is not using min-max, only the difference. So I can run from say 100. Just say max is as a range even. The range size is 0.01 till 10 or something. That should be enough. 11, whatever. Range size plus is 0.01. And then construct a NiceDelta from, I really sure it matter what to use here. So more than fits. Well, first of all, we see that the result is indeed always 1, 2, or 5 times some power of 10. Because it is clearly 1, 2, 5, a half, 0.2, 0.1, and then even 100th of that. Furthermore, this should be less than that one, right? Because you go down. Now this is very, very much less. I must say, because I think oh wait a minute, I'm dividing the range by 5, and then we want to find something in the neighborhood of that. So maybe I should print that. So what it looks like that I'm trying to do is divide the range by 5 and then find the first nice that is less and then increment it. So we try to find the first nice that is larger than the range divided by 5. Let's print that instead. Oh yeah, so if it is already the form 1, 2 or 5 times the power of 10, I just keep it that way, that is great. And otherwise we seek for the next one. This one is larger than 0.05, so we must go to 0.01, and this must go to that value, and this stays the same. And here indeed the next value is that. Correct, 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 and this one's not correct. But maybe this one is sneakily in tiny infinitesimal bit larger than the 0.02 that it's showing here. So now the question is, when do I want to do that? Do I not want to go to 0.02 here, even though it's tiny a little bit larger? This one I have to call correct. But yeah, if I do that, what if I have 0.0199? Do I still want to use... No, sorry, I mean 0.020001. Is that still 0.02? And then what about 0.0205? I mean, where do you draw the line? Maybe I draw the line at what theoretically could be floating point round off errors. So let's say in the neighborhood of a millionth of this value, the value that we can see. Is that reasonable? So that means I should just have to divide this by, or multiply it by, say, 0.99999, or something like that. But the whole division by 5 is already dubious, actually. It is super at the edge. It is actually a little bit too large already. I think I should use a brute force attempt to find the correct division. How do I find a floating point round off problem here? So I'm finding an integer, and it could be that my integer before taking the floor, it's something like blah blah .999 something. That would be a little bit sad to take the floor then. But yeah. Ha! It still does it. Well, that's even less than 0.02. Sorry, 0.02. Less than it. So they're totally not working. I want to debug this, step into it. How do we do that? That would be let's use a counter then. So this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, the 10th. Yes. GDB list main break 330 run step next. Range size here is 0.1. Then that is larger than 0.1. How the hell did the ideal thing get what? What did this printed something less than 0.02 after dividing by 5. This is larger. Something else is going wrong then. I'm using range size. I'm passing 3 puzzle range size, which gives me a problem, apparently. Adding 3 and then subtracting 3. Yeah. No, okay, I'll use 0 here. I mean, at some point you just have to give up with trying to correct for round off errors. That is a luxury that we don't have eventually, though. This kind of a round off errors will sneak in. I can also not imagine that the log 10 would do something horrible as returning something that is the floor of which is too low. It seems impossible. Is it? Yeah, I don't know. Okay, now it's correct. So even these values are not super exact. They cannot be stored apparently in a double. So this stays 0.5 until this becomes 0.05, and then we make that 0.1. No. Well, this is an infinitesimal little bit larger than 0.05. So theoretically, but I wanted to avoid that. I guess we do get the exponent right. So the exponent becomes a -1. And then we try 5 times a tenth. And apparently that is still less than this one. Yeah, and it is. Well, no, 5 times 100. Does that return -1? Let's debug this again, or 2 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 more. Do a quick test. No, there was one too large. Should have used 15. I mean 25. Okay, the ideal delta is in a little bit larger. Oh, yeah, that's probably this going to do it. But okay, what is the log 10 of that? Yeah, come on. Oops. Yeah, that should become -2 then, the floor. Yeah, and that is 100th. So this is totally does not come into play here at all. Exponent is just -2, and then we make the mistake here apparently. Calculating the value maybe. So now a value should return exactly 100, which is obviously still less than that. Yeah, so it continues and then it just says 0.05 exact. No, I can't do that exact actually. Anyway, next value, I try 0.02, which is also less than. And now we have the 0.05, which is very almost the same as the ideal delta. Nasty round error. So apparently 0.05 cannot be stored in a double, so we get a 1 here. And the way we calculate value, we don't even get near the optimal value. Well, we do kind of near, but that's the error is 3 times larger. What? But hey, now I think about it, this is not less. Oh, it is less. There's a 0 more. Oh, it's even more accurate. Sorry. No, I thought it was even worse. So this is worse. But okay, that one was calculated. Okay, I'm getting it. So this is indeed still smaller than that one. Yeah. Yeah. Well, I think we should call them equal, right? No matter what argument you can come with, it's not worth it going a whole factor 2 off. So while it is less, we do that, which means that if it is equal, then we don't do this. So it must be less, or it must be almost equal. Let's calculate the value only once. The current value and the ideal value. I think maybe this is not necessary. Let's comment that out until it turns out to be necessary. Oh God. Looks like an infinite loop. Now what? A very, very, very large exponent. I'm not updating. I'm not updating current value. So smart. Good. Yes, VI. Prog. Yeah, we're just at the bottom, I guess. Did I do this correctly? It feels wrong. I just negated the Boolean expression, didn't I not? But the result doesn't look good. This was the while condition, so I want to increment it if this is true. So I do not want to continue incrementing if this is false. And if you apply the not here, when you apply the not, then we have to apply the not to this and an and to the I mean, let's apply it very carefully. Like that. And then applying the not to this means simply testing it the other way around. So I negated it now. But now it looks wrong, because if they are almost equal, then I would like to break, actually, I think. Because I want to break if they are equal. So now I want to remove this. Well, maybe it was wrong to begin with. So we continue incrementing until the current value that we reached is greater or equal to the ideal value. But almost equal is good enough. Yeah. Infinite, infinite, infinite. I so hate it. Getting bugs like that. Mistakes like that. What am I doing wrong? Oh, must be an or. Still confusing. Okay, so this is now. No, this is still this is still exact. I mean, the next largest value is that. This is now correct. So that is the almost equal that fixed it. And then if you have a 2 here, then it says, well, that's not almost equal. So we go to the 0, 1. We remain at 0, 1 until this becomes larger than that. So this is still 0, 1, and here we get 0, 2. Yeah, I agree. Then it remains 0, 2 until, well, this is still 0, 2, great. Yeah, also correct. And then we remain half until, yeah, I agree with that. I totally agree with that. And then the next time we get here. Yep. Go to 5. Yeah, it just seems to work. I think that was the last one. Yeah. Yeah, took a little bit of effort, but now we have an tested constructor. And hope is that after this constructor, the returned value is such that my m is small enough. Meaning that a smaller m is definitely not the correct answer. In other words, the brute force m that we find is not allowed to be less than the current m. The m that we find like this. And we can test that. So I run over all test values here, and then you calculate with brute force the correct value for MBF and brute force. Yeah, well, maybe I need it. And then we calculate I'm not going to use this anymore, it doesn't work anyway. Construct a NiceDelta from the min and the max. And then the assertion is that dm is small enough, which means that bf is not less. NBF less is wrong. In other words, it must be greater or equal. Small enough. Just turn it around. This, yeah, should have come up with that immediately. Small enough means that it is possibly less, but at most equal to the correct value. Just a warning. Yay! Wow, that is actually working. And interestingly enough, now we can semi-brute force another value. For example, does 4 work? Well, I think that makes delta larger and m smaller. So this must certainly also work, because 5 already worked. But does 6 work? And it also works, which is not entirely surprising, but 7 should not work, because yeah, if I understood it correctly, then hopefully this does not work. Damn it, it also works. Well, then maybe I was mistaken and it should have been 9. So I'm just going to continue checking. At some point it should go wrong. Yep, it seems to have been 9 then. So the 9 should also work, please. Yes, thank you. But then the 10 should definitely fail. Thank God. So it is the 9. It is the 9. I took the wrong one. Still highly confusing, I must say, because yeah, we make it as small as possible. This makes m very large. So how the hell is that then still small now? Super strange. Well, no, wait a minute. That's not true. You can use 9 because it makes m larger, but not larger than 10. And if there exists a value all the way up till 10 at all, then that's the correct answer. So the brute force one will take that value then. So yeah, we should go for this. And then the only reason that it might be m needs to be even larger is then that even this value would still be less than 5. So I think that, for example, we are still going to have values where dm is less than 5. Let's calculate it. Int dm this just m. And then if m is less than 5, that is possible. It should never be larger than 12 though. Should it? Can it? No, I think it should be less than 10 even, always, because of the divide by 9. So less or equal 10, I think. Now less than 5 can happen, I think. Let's just print, or this count. Yeah, let's first test this assert. that works. So yeah, we get something that's less than or equal to 10. Absolutely super nice. And then I can just print all the cases that it is still the wrong answer. Namely, if it is unequal BF, MBF, and yeah, if that is not the case, so if this is equal, then this better be the case, because well, then it really must be almost equal, the delta value. So that would also be wrong, but more, yeah, more like an assert. I would rather assert on that. It's way more serious than that. So in the case of success, that is our M is equal to the correct one, the brute force calculated one. Then also the delta must be almost equal. And now we only print the case, only print the values where NiceDelta is incorrect still. Or we don't, because this means that we cannot print something. I can't print NiceDelta. I'm trying to print NiceDelta. Well. So there are still loads that don't work, but now we can easily fix this. For example, I'll pick one. I don't know. These are nice and short. So I must decrement D. So we find D is 5 with an M of 4. Oh, we definitely must decrement it here, because M is 4 is not even allowed. So if M is less than 5, then we just always decrement D. And then it becomes 2, and then we get the value of 10, and that is, we accept that anyway, even if it had to be 11. So let's find a case where that is the case. Let's write to the top. So I want to find a case where this is 11, so like that. I'll rather work with integers at the moment. So for example, this one. Yeah, so we have the decrement, we found 50. That's still m is 4. Yeah, okay, that obviously I would say. So because m equals 4, we always must decrement it. So we go regardless to 20 and then m becomes 11, but we don't care. While, for example, this one, where m is not 4, we increment it anyway, because it's decremented anyway, I mean, because by decrementing it, that is going from 10 to the power minus 7 to 5 times 10 to the power minus 8, increments m to 10, and that's still less than or equal 10. Therefore, we accept that one. I was just going to say that, and this means that it always has to be 4 or 5. That is not true. Apparently, it can also be 3, but it's also less than 5. So I think that m here is always less than or equal 5. It cannot be 6 or larger. So if search for m is 6, we would not find that. Nor there is a 7 or an 8 or 9 or a 10 or, well, definitely not an 11, because you already asserted that it is less or equal 10. There are a lot of 5s. And there are a lot of 4s. And there are even some 3s apparently. I doubt that there are 2s. I don't think that's possible. No. Well, this looks incredibly sane. So let's finish it now. And then poke out the eyes of the AI, saying, look, this is what you should have written. And it's gonna say, oh, this is much more clean and short, and then kiss my feet. Okay, enough of that. So far I don't need to decrement either. Delete it. To make it even shorter. Shorter. Yeah, maybe you can call that an initialization as well. Yeah, I think we might as well do this inside. Actually, I don't need this and outside anymore. Let's make this private. When it is private anyway, I might as well not use... actually, I only need it here, so I might as well inline it. Looks silly. I don't need to store min and max. Yeah. I just want to get my M. So I might as well calculate M and then store that. And then use an accessor on it. And the question of how often do I use value? I also only use that here. Well, not quite, because after construction we need to turn this value. I could turn it into a function now, which is a one-time construction, and then we have values. No, yeah. Oh, I need an increment anyway, because I still need to increment it after this, and I don't want duplicated code. So let's call it just increment. But I have to try and increment it. I would really like to have M be an accessor and not store min and max. I think I can do that, right? Let's make this, these are the main variables, nice integers, no round off problems. And then I'm going to store M value. And then M is just an accessor. This is just going to reach. Oh, I'll need a code for it, of course. Somewhere. This is just an accessor. Return M. And then I don't have min and max anymore, so instead of min and max underscore, we just use it directly, which is then apparently only going to be there. I already used the max and min here, like that. And then this is calculation of an M value. And we might as well start with writing that to M underscore. Now we do need current value here, so yeah, then I want to put the current value outside this loop. So I still have it here. And then if M is less than 5, he must always increment it. But I must increment it anyway to test. Although, well, I think it's not necessary to test it if M is larger than 5. So if M is larger than 5, we are done. really. Because you can only step a minimum factor is a factor of 2. So it is already larger than 5, then the next value is larger than 10. And then we might as well calculate in the next m, as it were. And yeah, no code duplication, so this now must become a function, really. But it can be a static function, a private static function even. So you have a static int calculate m. Which needs to be passed, min and max, and the value. Yeah, so the next value is then an increment still, but not called on the current object, preferable. How often am I calling that? Just once here. Oh, and again here. No, okay. Yeah, well, I'm afraid we'll have to make a copy of the current object then. No, I should try to decrement it. Well, I don't have a decrement function because I deleted it. So I might as well do that one inline then. Is that stupid? Should I just add a decrement? Make a copy, everything. Nah, I need a value call on it as well. Can inline everything there, including the value and stuff. Okay, let's just write an extra member function, but then only if this becomes something really beautiful. So no copy of stuff, no separate increment. I just want to call get the next value. But if I want to use value, I have to use value. I kind of need a new object. Yeah, actually it is the next m because m increments. So previous delta, next m. Look at that. Make a decrement that returns a decremented value. Which then we don't need to store even, can be a temporary. And then might as well have decrement return value immediately. Yeah, maybe not. Dubious. Anyway, then I need a decrement here, which definitely can be private. which is going to return a nice delta by value. And then I want to have a constructor, which actually also can be private in. Or I can just pass I don't have to do the M, I just want to calculate the value from it. See, I don't want to construct a nice delta. But then I would have to duplicate value, which I also don't want. Let's move the value also to a static function, I think. Although that's kind of silly because I need mantissa values. Well, that's a static already. But then I would have to pass mantissa and exponent to it. But yeah, that's not too bad, I guess. I don't know. It doesn't feel. So the problem is, I mean, if you don't want code duplications or don't want to just copy this line here, I need an object to call value on it, because we do need the value of the next D. But this function doesn't use M. And I'm like, why would I calculate M just to initialize a new object? Well, I don't even need it. Whatever. It's a private constructor, so I can just do that and then add a comment, I guess. It feels so dirty. But okay, int this I'm very unhappy with this. I don't know, it just doesn't feel correct at all. Might as well put a decrement inside this constructor then. So construct the next smaller. NiceDelta from a given mantissa and exponents. put the mantissa first. I have a better idea. Let's just do the +1 already there down there. And then this just has to canonicalize it. Which reads a lot better. So yeah, the mantissa here is first. So the next smaller value, oh, I have to decrement it. What am I doing? Smaller value, NiceDelta, let me think. Yeah, to decrement it. So I pass -1. And then it looks like, hey, we decremented it. Yeah. Yeah, this is not a no decrement, of course. So this is then construct NiceDelta from a given mantissa an exponent. This still holds, I guess. And then I just begin with putting them in. So now if this was if it became 0, yeah, that is the thing, right? It's like this. But that's not canonicalized anymore because maybe I want to pass a mantissa that is even 10 or something like that. But it's a private one and I know that I only subtract something. Okay, let's say this constructor accepts a mantissa in the range and then 0 inclusive. Oh, why not? You can even increment it then. I mean, I'll just support that. Although then I need to change the exponent as well. Just not do that. So it is already correct unless the mantissa equals 0. Sorry, it cannot be 0. This is the mantissa. This passes an index actually. So it is -1. Yeah. Yep, so if it's -1, then this turns it into number of mantissa values -1, which is the largest allowed value. Maybe make that more explicit by type that in and then do it inclusive. And yeah, if I restrict myself to just this, then I don't need to do modulo really. The mantissa is already correct, unless this is needed. It's a very restrictive constructor, but it's private anyway, so I don't care. So, now I call increment there. This should be decrement as well. Do I have a copy constructor? I'm not sure. I don't think if I define this and copy constructor, the compiler generated copy constructor is gone. So yeah, I might as well put it here because I don't need a copy constructor, or do I need a copy constructor? Well, maybe I need a copy constructor anyway. I just don't like the sight of a start at this here. I mean, you would have to do start this is next. Smaller delta. I just don't like that much. Yeah, I think this is doing it. Yeah. template argument list, seriously. Failure. No, hardly. I didn't update M. So these are all correct now. But I left M at what it was. Oh yeah, of course, because now we generate the correct value, and this assertion does no longer hold. It is now less than or equal 12, but don't have to test that because it's just no longer true. I get the M value and the D value from this, and then we can just test if everything is correct. And it is. This works. What the hell? Can try random values. Probably goes wrong at some point though. No? I don't have this anymore actually. That was just to find something. Maybe the whole random thing is overrated. Yeah, it's a very small range anyway. But I think, well, we have to test it. I'm just scared it fails. Let's try, what is it? 10 million random values in that range as well. And this can all be deleted because it is HTTP nonsense and my own failure nonsense. Me. And a tick count. Yeah. Wait a minute. The int 64 type. Kind of don't have that anymore, which is probably not good. Yeah, I don't need this anymore, do I? I don't think I need this anymore. Brute force, okay, we still use that. It's just a variable name. That's used by the brute force one. Only by the brute force one. That is not true. Well, that is a static function. Actually, not a bad idea to calculate the standard floor of a double returns a double. Yeah, so and then just continue with the double, and then in the end we still have an integer. So it's kind of safe to just dump that into an int, because this definitely should be small enough. No longer overflow an int. Is there a reason we want to static cast this? I didn't get a warning from it, but okay. Let's static cast this to an int then afterwards, after doing the subtraction. Because we saw that the initially calculated m was 3 till 10 or something like that. Definitely fits in it. Okay, delete that as well then. Yeah, that just works. Very good. Is D being used? I think it's still being used, but yeah, it's used also by brute force stuff. Huh? Before it took like a half minute. Oh, this is the... Yeah, sorry, that was those were the random numbers. This is just way fast. Okay. Now, one last interesting thing to test, I think, is if my new code now is not using the almost equal. Will then we indeed see something go wrong or not? So we comment this out and purely rely on being it exactly greater or equal. That should go wrong, yeah? And go wrong means assert, but before we assert, then it does print this. Maybe I don't want to assert anymore. I just want to see all of them. Ah, nothing. Seriously. Hmm. That's strange. That feels a bit strange. Yeah, okay. I'm still not really willing to remove it. Or shall I just remove it? If in all my tests, it is never necessary. How is that even possible? I'm sure we had cases where this did matter. So let's say almost equal returns true. Well, this is still false. That means that we would break early, so we would do an increment less. And that is kind of the same as doing the decrement anyway. So maybe in those cases the decrement was done if we exited here after doing the increment. So let's say it is, wait a minute, or almost equal. So yeah, we do an increment more. Okay, yeah, so we do what? Wait a minute. So by removing the almost equal, I would do an extra increment, yes? Don't do the break. And then we end up with very likely an delta that is too large because we did extra increment. Which means that then M1 is either too small, so that we do another decrement. Or, well, we test that decrement anyway here, and then this still holds. So apparently it just fixes itself by this code. Yeah, okay. Yeah. Okay. I convinced myself. I still think about it longer. This is then the final code. I'll run it one more time. And now we'll move it into, gonna move it into the project, I think. And just keep it as a test. Where's my projects? Here, for example. I don't really have tests here. Well, that would be the first test then. Well, draw coordinates is a test. Yeah. Okay, I need a name for this thing. Just copy it from the. Let's copy it here. So I'm gonna do move from the home directory to NiceDelta test. I'm just going to use utils and debug output, I suppose. Probably should only do this if debugging is turned on. Yeah, the whole project is one big debug thing project. I don't care. So. Let's fix it for AICXX stuff. So we need to include systol.h at the start. No longer use this. We no longer use this, I think. Well, actually I do in 64, yeah, for the brute force stuff. Limits, I think we still use that. Precision, I still have a vector. Nobody knows what utilities are for. This is going to be replaced. Math, yeah, definitely. IO stream. No, I'm gonna go to. Well, maybe I do actually. Still use standard. See how that is for certain things. Okay, all my asserts should change into capital asserts. Because why not? And then I don't have many of these actually. Set position changed. Okay, so we lose that one then, including the IO manip. And I'll use here debug output. That would be a warning, I guess. But yeah, then also this will fail. Need to initialize the debugging library. Namespace debug init. Yeah, that's it. Great, great, great. Now we can delete almost equal. And you also use utils. Although that is only used for the brute force and debugging now. Actually, it's only used for debugging. Do I need utilities still? I don't know. Nope. Although maybe that is included by debug.h. We'll never know now. No, I don't think I need it. I do need array though. It's being used here, I now see. Let's have a quick scan, but at least a NiceDelta. It's ported. Chance floor, that's CMOS. I'm smelling something burning. Ish. Or do I? Hold on. I don't know. So my PC is not burning, so that's everything is okay. If there was a burning smell coming out of my PC, then the stream would have been cut short, definitely. Yeah, what is next? I have to put the NiceDelta in its own header. Yeah, that's all. Definitely use that, yeah. Not using limits anymore, do I? Yes, probably whip. It does compile, however. But. It is whip, isn't it? I don't know anymore what I was doing. Let's mostly work on this. Constructor of coordinate system. Okay, git commit. And I committed no, yeah, whatever. Doesn't compile then. Dirt. Also using divided by 9. It equals 10, you're done. It's slightly different. Yeah, once or twice. Nope, just once is enough. No, it's just a compact NiceDelta that implements this. It assumes you have tick count, no longer needed. D, the whole class. It left the whole class out. Nice, you want to do it small, nice value, blah blah blah. Reasonably small, but so don't have that anymore. Yeah, well, sorry, but I woke up with a much more clear picture of I'm definitely smelling something burning. Damn it, sorry, I have to investigate this. No, I don't know. Nothing. Probably just a small brain infarct, I guess. I think you need at least two signs. So you smell something and then have the one half of your face muscles. Well, you know, the last thing is still lacking, so I'm probably okay. Let me drink something. But yeah, weird. 2.5, but I was including all kinds of testing and stuff. I'll do this again, just in case. Checking. Yes. Great. Yeah, I already tested it, Mr. AI, so you better don't find some problem with it. That would reflect bad on you. How the hell would this be possible? Yeah, I think this is just true in 100% of the cases. So it just makes no sense whatsoever to test it. It is just true, so that's why I left it out. No, and that is not possible. That's it still wants to keep looping, but no, I'll give the feedback. So 1 next M larger than M is always true because we just decremented NiceDelta. I'm no longer doing that. um, I'm no longer doing that. I could do that. If the initial m is larger than 5, then I don't have to calculate this. Hmm. Yeah. So it's saying I have already called value, which calculated this. And then if we decrement it and we don't get an underflow, then we already calculated this. Yeah, come on. I mean, that would make the code so much bigger and more unreadable. Just to have that separately cached. My intuition says that it's, that one should definitely not do that. I don't know how to explain that to the AI though. Nou ja, and so on. Let's continue actually coding by using this now. So we calculate intersection points of the axis, the rotated axis of a coordinate system, with the rectangle of the window, getting 4 points, namely these 2 points times the 2 axes that we have. And then let's concentrate on a single axis, aka a single loop. Time that we go through the loop. These are in pixels. We can calculate them in pixels because, well, the rectangle is in pixels. Yeah, this code was changed a lot. So at some point I started to use a line piece. Oh, I just do that to print it apparently. I don't think I'm even using that anymore. Oh, it's being used here on display. Oh, right, yeah, okay, never mind. Those are the line pieces are the part of the axis that is visible, right? That's just simply from one intersection point to the next. And I store that so I can draw them. So this is part of the coordinate system axis that we have to draw later on. And it's being calculated, but then also printed. And then here we convert back the endpoints to the coordinate system, the current coordinate system of the coordinate system that I'm showing. And then we calculate the minimum and maximum value in CS coordinate system value, so the CS here, as opposed to pixels. And that is my range. So now you have to use the delta, the NiceDelta on this range to calculate the number of tick marks. But I already have a set range. Then actually that is the one that has to do it, I think, yeah. So set range is, I think, a member function, yeah. This gets a range using range CS. Maybe I should change the NiceDelta to be a template as well using CS. So I store the range. At this point, not sure anymore if I even need that. And I could have used NiceDelta. I would have stored the min and the max inside the NiceDelta, but I decided not to do that. So don't have it anymore. Okay. So kind of sad. I like it that these are just integers. Definitely like that. I can change it, I suppose. I can construct a NiceDelta from it's called NiceDelta. I'm just gonna call it delta. It's constructed from the range like that. And in fact, if NiceDelta would also remember the range, then we could do it just one array. Because then both the range is stored as well as, well, the range ticks, and the number of ticks is m. M is actually the number of ticks. I'll keep them separately. I'm going to initialize this as well with something. Oh, it is initialized. Well, it is initialized with a default constructed range. I don't want that. Because that is uninitialized. No, it's not. 0, 1. Okay, this is okay, era window range. But I bet that my own range is just derived from that. Okay, well I don't want a range of 0, 1. So default constructed here means 0, 1, 0 to 1. Yeah, that's nonsense. Let me initialize this with do we need to initialize a list here? Probably. I think I can just do it like this. What was the range taking? Oh, I've got again. Well, 2 values, I suppose. Let's make an empty range. I don't know how many I have these needed. It's probably maybe one less. I don't know. Let's try one less first. Oh, actually, this belongs here. 0 means not visible. And here 0 means don't draw ticks. So this changed the NiceDelta into a template, and we pass now a range CS to constructor of NiceDelta. CS is just an enum for the which coordinate system it is. And then this constructor keeps. This constructor now should be changed into taking a range. The range CS. And that thing lives in global namespace here. That needs to include it, of course. Install A, so we don't need that anymore. .h, I mean, where's my range? The source range here. Does already have this cs.h. This range is template, it takes the CS. You can print it. and it does have a size, I think. This is derived from this one, and this one has a size. This just has min and max accessors. I think it compiles again, except now, of course, the test doesn't compile. Expected semicolon. Still doesn't know CS. NiceDelta, I mean. A minute maxi tags. No, I don't include it. Yeah, no valve conversion from double to range. So it thinks that this is a. So I need even more brushes. The ridiculousness of it all. Assigning value type int to, okay, yeah, range sticks needs to be changed now to store NiceDelta. NiceDelta CS even. Yeah, that's possible because this whole class is coordinate system CS. Config tag pattern. You gotta be kidding me, right? Here it is. They should store also ranges now. What? No, nonsense. NiceDelta. Which then needs to be constructed from not 0, but delta, that is 0, is equal to 0. Oh, which is not possible. How about a default constructed NiceDelta? Currently don't have that. or constructed from an empty range or something like that. But that of course wouldn't work. Then ideal delta is 0 and then this blows up. Can't do that. So make a default constructor which just sets the values to something nonsensical. This -1. Theoretically, you can also test that it is. I'm even gonna use unequal -1. I think -1 is just a magic value here. It's not the way you should do it. Let's add a const expression int invalid magic. And here we have a mint this that is equal -1, so we cannot use -1. Let's use the other side. Is that reasonable, or shall I just use -2? Valid magic. That's probably printing noise value. Yeah, I'll have to add support for that as well. Did I say noise value or did I say NiceDelta? I meant on NiceDelta. If div cw debug and if void print on standard stream reference is const, and then we print the thing. Let's print a dot, center dot, so it's easy to recognize that this is that is this object. Of course, I don't know what it is. I think I have a utils support to print an exponent in. You know, a little exponent. Well, I've got what the name is, of course. Let's see if we can find that back. Probably in utils. I can never find anything back anymore. Probably something with exponent in it. I don't see it. Nope. Well, maybe it's not here then. I don't know. Where could it be? Or it's hidden in a debug file maybe, or just in another project. Yeah, I don't know. I can't find it back. Let's just use carrots then. Yeah, it wouldn't be exponent, right? It would be more like there's another way to find this. Superscript. Took me a very long time to remember that word. Also not. Nope. No, then I don't know. Very sure I wrote that once. Use superscript to print numbers. Yeah, this is the test. So we have a range here, but it wants to know which CS to use for that. I'll have value return the pixel. Nah, it's just a single value. It is in pixels, but still. It compiles. How is that even possible? Was in the constructor of coordinate system. No, where the hell is my coordinate system? Constructor. Actually, I was working here as well. Where is it? Oh, that's in the .cxx file. Yeah, so our range ticks now store NiceDelta, which is has the correct value, and we're printing it. Actually, there's something missing from the printing. We should print here the which coordinate system it is. You're just printing the value now. There's more, right? There's more. I can print more. M. I can print M. Let's print M as well. So I'm going to add braces around it. And then I'll print, yeah, M, I think. Like that. Let's run the thing. Yeah, it's rotated 80 degrees. Do I still want to work with that? Yeah, set range is being called for painter. Centered is maybe not super interesting. So painter is the red one. And that does the following. There. Range ticks. So the range is in painter coordinates from minus 0.7, which is here, to 1.241. That is there, just along this axis. This is the x-axis. It's rotated a lot. This is the origin. This is minus 0.7, and this is plus 1.24. And then it says the range ticks must be done in steps of 0.2, which will give you 10 visible ticks. I would say, of course, a tick mark is at the origin, so that gives us all the way up till 1.2. The next one would be 1.4. That's an off the screen, so out of the window. So this gives us, including the origin, so the origin, and then 0.2, 0.4, 0.6, 0.8, 1, 1.2. That's 7. And then the other way is minus 0.2, minus 0.4, minus 0.6, and that is 10, and then minus 0.8, which is again off the screen, or out of the window, I mean. Off the screen, that would be something. Yeah, okay, so Totally correct. Awesome. And then we have another one here. Surprisingly, that gives us only 5 tick marks. Apparently I do rather 5 tick marks than more than 10 in this case. More than 10. I mean, yeah, you have to draw the line somewhere, but 5 is not a lot, of course. But on the other hand, well, you get 1 here and then maybe 1, 2, and then well, probably 3 on this side and 1 on this side. I don't know. It's doing. I would want to know how long this is. I know it's 100 pixels, but what is the length in CS? What is it? Painter coordinates. Probably this one, 0.444, I think. Yeah. And the tick marks it says is 50, so it's gonna put a tick mark here. And I think the next one drops off. Let's see if that's indeed the case. Yeah, so it is. This is the positive direction. So we get 1 at 0.5, and then the next one is 1, which is outside the window. And then the origin is 2, and then we should get 3 tick marks on this side. Namely minus 0.5, minus 1, and minus 1.5. Yeah, well, why not, you know? Can't have too many tick marks. Right, so yeah, I think it's time to actually draw the tick marks. Should be able to do that now. Where do we do the drawing? Was it not here? Completely lost. Display. Nope. Oh, that doesn't even exist. That's shocking. Oh, it's okay. It's a template. Not shocking. So this is drawing the red lines, 2 axes, but we also want to draw all the tick marks, of course. Well, this is testing if the axis itself is visible, because if not, then we continue. Not if the tick marks are visible. So I should look at a range. And then I will set it to empty. I think I hope I have an empty. Do we have an empty? Well, range is storing range, which is derived from this, and we don't have an empty. But we have a size. I'm creating this with like 0, 0. I think that the computer is able to subtract 0 from 0 and then return exactly 0. Although it is, of course, a tiny little bit scary. But not really scary, right? I mean, if doubles are integers, then they have infinite position, period. So I think we can just test this as the size equals 0.0. So if the range is empty, then min equals max Mathematics is 0. And size will return 0 exactly. Then we can draw them, and then after we draw it, you might as well draw the tick marks, you know. So draw the tick marks. So we're going to draw the tick marks for the current axis. I need to loop over k values. So we have a k1, it's a start value. We're going to have a k2, which is the end value. The start value is or I can just start it at 0. Nah, let's try to calculate a k1. Is k1 not something that we can grab directly from? No, we cannot, because I'm not storing min and max inside the NiceDelta. Starting to regret it. Yeah, let's call it k min and max actually, because that's more like it. Let's begin with k max. K max would be the smallest, therefore we need a floor. The smallest k value such that k times delta, therefore we must divide by it. And of course how it is called, I think just range sticks. Axis value. No, not size, the maximum, Is this correct? Yeah, looks correct. So ignoring the floor, if you multiply both sides with the NiceDelta value, that belongs to this axis, then we have k times delta equals maximum value. But we need a little bit smaller k in case that is a floating point value. So it's still, that tick mark still is visible. And then k min is probably the standard ceiling of range min divided by the same value, yeah, because I say so. Well, my subconscious says so. I just replace floor with ceiling and min with max, or max with min, I mean. But that's how it works, I think, yeah. And then we can run over all k values. And we don't want to draw anything if this is invalid. invalid. Continue. Now we're done. And now we're talking about axis. Hey, Katilana. Just C++ or all years that I coded near daily, which is all my life. That would be I need to calculate. Well, plus about 1 year, right? Started. I think I started. No, I started there. Yeah, 31 years. C++ is now, I think, at 31 years. Yeah, otherwise I would feel bad that I'm streaming what I'm doing. That's like, you know, I would feel like a loser if I had only 5 years of experience. But now I can tell myself, well, you know, maybe it's useful for someone. Although I'm not pretending to be useful, I'm just working. Maybe it's interesting. I don't know, something like that. Yeah, I sound younger than I am, I guess. I also look younger than I am, for that matter. I'm 61. So I started at C++ only when I was 30. But hey, that was even before the C++ was standardized, so I have an excuse. I started coding when I was 12. I definitely have to say that does create certain neural patterns in your brain. I think if you, I've coded quite phonetically starting at 12. I just loved writing programs, but not in C++. No. Mostly in a language called GFA Basic. Does that still exist? It sounds like Basic. It was more like Pascal-ish. Pascal with line numbers or something like that. But I didn't start in GFA Basic. That didn't exist yet. When I was 12, I started on a TRS-80. Yeah, this is what I coded when I was really young. There's no line numbers. Oh man, that looks horrible. I started coding on a TRS-80, which I think had BASIC also. Must have been pure BASIC. Oh, thank you. I've always looked 6 years, which is now almost nothing, of course. But when I was young, even a teenager, I looked 6 years younger than I was. And I did get lines in my face pretty late as well. But yeah, when the lines and the sagging of my cheeks is starting. That really adds to your age. Nobody would think I'm 12 years younger than I am, which did happen at some point. And I was 29, I think. Yeah, when I was 29, someone thought I was 17. That's my record. Let me see. I hope my brain is also still younger than 61. It might help that I still code every day. Okay. Yeah, so I'm going to draw the tick marks because they are valid. We calculate to k min and max k value, run over it, and now we have one single tick mark to calculate. Which means that at first we want to calculate the actual nice value. To double, let's call that so that is the value in CS coordinates. I'm just going to call it value CS. I don't have a value class, so I can't make it a template, but we can tag it with the CS. And that should be k times the delta value. Maybe I should lift out the delta value as well. Let's say we make that a double as well. Delta in CS coordinates. But what happens? You see it jumped to the top and deleted it. My God, there. No, don't do that. Bleep. Burp. Yeah, okay, so that's better. Now we have the delta value, and we can just multiply with it. This is the value on the axis. So I have to convert this into a point, otherwise I can't apply my transformation to pixels. And that depends then on the axis, which is kind of annoying, but so we need a point in CS coordinates on the, and that is the point on the axis. I need also a normal vector actually. I need a point and a direction, otherwise we can't start to draw that stuff. How shall I call the tick mark point? The point at which the tick mark starts. Don't call it tick. And we have to construct this thing from an x coordinate and a y coordinate, and it depends on the axis which one. So if the axis equals the x-axis, then so x-axis I don't think is horizontal, then of course the y is 0, and the x-axis is then this value. Yeah, otherwise it's going to be 0. And then here the other way around. Let's just make this a y-axis then. So if it's the y-axis, then I use the value, otherwise we use 0 again. Let's make a unity vector that points in the direction of this axis. Can I make a direction? A direction is a vector, I think. Do I have a direction CS? I'm not even sure. Not even sure. I think I don't. math direction. That's basically where it stops, isn't it? Okay, I can't work with directions because we don't have it. Maybe vector. Vector. Okay, on the vector, math vector, utils vector. Why? I don't have a vector. Okay, that gets annoying. I have to add one of these. Or shall I first finish the code for the point? I can just draw something and then we'll see that it is more or less at the correct place. So this tick here is in CS coordinates. So let's now convert it to pixels. Point coordinate system pixels is then tick tock pixels is tick CS times, and then that must be TS transform pixels as per my convention, although I don't know if I have that. I totally have it. Haha, evil laughter, yes. It's even passed to the class. So now we have the point in pixels. Yeah, no, okay, draw something. You can only draw lines at the moment, I think. Well, I can draw lines and text maybe. Lines, line piece. No. Only the vector here is a shared pointer of stuff. So pretty minimal, isn't it? Only lines, but yeah. I want to draw something. I want to see if it works already. So I'm gonna draw a line at, let's do pass 2 points to just the point itself, I suppose. Tick pixels dot x, comma tick pixels dot y, comma, and then I suppose the same thing, but then let's make a horizontal line. For now, let's make a vertical line. So in fact, let's add 10 here and subtract 10 here. Maybe I should just draw 2 of those. I'm gonna use the same style because we don't have another style. I can change the style, by the way. I can just change the color by, I think, doing this and then change the color. So I'll do that. I think axis style is just a line style. Let's make it, let's try to give it a different color. So it's something like that. Dot line color is color, I don't know, yellow, no, orange, blue. I didn't use blue yet. Yep, and I'm gonna draw another line from -10 to +10, changing that. X coordinate. Now this is probably not going to compile, but then we'll fix it. Don't type 31 behind. How the hell did 31 get there? What? And I thought I had it. CS transform pixels. This is not. Oh, this is in display. Yeah, well, have to store it then. Make it a member. Starting to regret that I have a separate member function for. And it was already stored. Yeah, for some reason I called it reference transform. Let me just rename that to what it should be then. I mean, come on, it's just CS transform pixels. Pixels. Oh my god, it compiled. Cross fingers that this is gonna draw something nice. Nope, nothing. Okay, well, we don't see anything. Therefore, the first question is then, what did it draw? What did it attempt to draw? Did we even get there? That is the first question. It might be that we never get here because of this, for example, that the range text is just never valid. Let's add debug output here for another thing, namely if we are going to loop at all. Kmin is kmin and kmax is kmax. So if this is not being printed, then this is probably always invalid for some reason. It should never happen though. I don't expect this to be the case, but let's add a highlight there. Yeah, we get there. Yeah, no. And the loop is non-zero. So this one runs from, okay, the x-axis is first, and this is the x-axis. And I'm pretty sure that this is the smaller value. Oh yeah, we had 10 in total. So we run from -3 to +6. That's -3, -2, -1. That's 3 here. And then the 0 and then 6 here. The 3 + 6 + 1 is 10 in total. It's just 10 here. And the other one is -3 to 1. And that the minus is here. So yeah, 3 + 1 plus that one is 5 in total. So that's correct. We get there, and we get there for every tick mark. Therefore, we'll actually get here and yeah, let's just print let's just print this value for now. in case that goes wrong, let's also print this one. So we understand which one is to blame. I'm smelling it again. I don't know what it is. Just very short. And then I try to smell it again and it's gone. Strange. Beep, 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 beep. Well, these values are correct. The minus 0.6, x is minus 0.6 and y is 0. That would be in this range as determined before. Yeah, minus 0.6 and then we get minus 0.4, minus 0.2, 0, blah, 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 all the way up to 1.2. Yeah, and then the next one is 1.4. That would be outside that range, and this one runs from minus 1.5, and the next one would be, well, previous one would be minus 2. So that is just inside this range, and then the last one is a half, because the next one is 1. Totally correct. And then converting it, well, this is all inside the window, so why am I not seeing anything? For example, this one, x is 0, y is a half. That would be there. And it is, x is about 90, 300, 190, so correct. 194. Okay, this is 0, this is 225. So I bet then that is 194. Also correct. Yet it isn't drawing anything. Oh, it is drawing it and then erasing it immediately again. Well, I saw that one before. But we are adding it to lines, which is the same as this one. Oh, now I see it. I forget to call this. Oh boy. Yeah. We add the correct stuff to lines vector and then never draw it. Brilliant. So much debugging, all for nothing. I'm going to even erase this because it just works. I just know it works. Yep, that is correct. So that's where the tick marks should go. So the reason we have so many here is that I like to have this many, apparently. Because 10 is still preferred. Don't necessarily have to write the values at it, but that number of tick marks, yeah, why not? Okay, now to draw the little tick marks, we need to have a direction as well. And that means I need to have a little direction vector in whatever direction. Let's make it point to in the positive direction of the current axis, I would say. And then transform that. So I need to be able to transform something. What do I have? I have a size. Well, that is size is not a direction. It's not a direction. It's not a vector. What the hell? Ground zero right here. I just don't have it. I have a vector here, but nah, it's not a translation vector. This. Nope, I think we have a point and a rectangle, and what is missing is a vector. Very simple. So I'm gonna copy point to a vector after checking that there's really no vector. There's really no vector. And then copy vector. Now edit vector, I mean. And then replace all points with the vector. And then check how it looks. Construct origin. I don't know. What is a default constructed vector? An empty vector? It's nothing. What about this? Well, I could construct a vector from 2 points, or we can just say, screw it. Use exactly the same as we had there, the same constructors. And this thing allows me to add a size to the point. Do I want to allow myself something like that? No. Maybe do we have, well, that depends. So I have rectangles and points already, and vectors of course. So we would have to look at the this is the Cairo in the vector. So it's basically just a math vector. I have a separate thing that allows me to copy from a math vector. Whatever. The math vector does have, this is not a math vector. The math vector has dot and cross product with another vector. So we probably have to add that. Can construct a vector from a point though. Yeah. And the S point would return something that we don't want to work with. Everywhere where this is using point, vector or rectangle, I would have to overload it. And then replace that with the one that is tagged with the coordinate system. In other words, a rectangle. Unexpected. Just kidding. Point. There's a lot of points, so. And vector itself. Yeah, I'm even going to need this one. Huh? Rotate the thing 90 degrees and stuff like that. I hate it to have to copy all this just because the type isn't correct. Well, maybe not really copy, but just make an inline member that casts the type. Well, that's only if you... wait a minute. Yeah. I can pass like any point or vector to the functions that take a vector as argument, because they are derived from this type. But then that would go horribly wrong. So it's just not type safe anymore. I could overload it. I could repeat all of them with the correct type. I don't think I have to redo the actual implementation, but we have to mention all the functions. All the functions. But yeah, it's not as bad as code duplication. Unless I add something to this class later on that accepts a math type, then we could run into some kind of non-type safe bug later on. It's far-fetched enough, I guess. I don't have a line piece, so yeah. Should I not make this one explicit as well? Can construct a line piece non-explicit from 2 points. And we already have that here. I'm definitely making this one explicit. It's but yeah, it still doesn't safeguard us from passing a line piece, of course, having a line piece. I don't have a line piece CS, so these ones. Okay, I'm starting to copy. So I want to copy from this to the new vector. Can I already do that? Nope. Oh, I thought my editor was smarter than that. It is. It just doesn't exist if you don't type the .h. I thought I was smarter than that. Okay, dot. So we start with this one. This can be removed. There's also public, isn't it? You suddenly switch from public to public. It's very confusing. This returns a vector reference, but it also takes a vector. But what about this one? I have to repeat that one as well. I am afraid. Basically all of them. Everything, even the vector reference. If it returns, I mean. And that's the end, yay. Well, no, there's one here. This is the end. Although I could even overload the print on to actually, yeah, and we have to do that as well. And then we're not done because we have a lot of free functions. But okay, let's begin with the member functions. Copy all of those. Paste all of them. Now, even though this is not template, it's now gonna use that the vector, the current one. I think you don't have to explicitly say that it is a template if you're inside class. So this already works, but now it's code duplication, which I really don't like. Although I doubt I will ever change that, it's still code duplication. So theoretically, what I want to do is call the base class dot passing a v2. It's where you need a meta programming language. You could just say, for all these functions, do this. But yeah, maybe one day after they added reflection. Oh, wait a minute, I have to cast this because this returns I would not have to cast this if I allow to construct my own class vector from the base class. Maybe that's a good reason to do this. And I could even make that private. Otherwise I get cast all over the place. But hey, if this thing has a copy constructor, then we can already do that, because we use this. It might actually work without, because this using the copy constructor of the base class would do the exact same thing as this. Methinks. So try it like that. So the casting might not be necessary. Casting 2 vector here, but only if we return by copy. And this returns a reference, so yeah, definitely I'm going to need a cast. So we want to call the base class implementation like that, and then the thing that it returns, we return that after casting it. Set a cast to something. This something being well, this turned value. And then of course you do the same thing here with a minus. And again, no, not entirely the same, but I'll just retype it. Return static cast base class operators. Actually, it is the same. Well, no, it is not. No, it's called scalar. Oops. Another scalar, division. And that looks like very much. Oh no, that's just division, not assignment. No. Oh, it is by value again. Returns, of course, by value. So no need to cast then. It's gonna call copy constructor, hopefully. And you want to overload this one in order to print in front of it the name of the coordinate system. To string CS. Sorry, blop. Followed by the base class implementation. Right. Yeah, we don't have a size. Fortunately, I do have a point. I'm going to use point because the point has the print on stuff. It doesn't. Why not? Because the size does it. The size has it. Why would the size have it? But the size has it. That has this and this, so we don't need that then in point with include size, and we don't need it here because we include point. Okay, now we'll back to the base class and then find the rest. there was more free functions, like only a few actually. Let's copy these as well. There's not going to be as much point stuff, I think. We already have those as well now. All of these are now templates because they are free functions, so I have to repeat it. It doesn't want to jump to. So what is wrong then? Well, for example, this is wrong. Free templates. I'm handing out free templates to the free functions. I don't even have to use CS here, or do I do? Do I need to? Do I? Yes, I do. Of course I do. Huh? What a question. I even have to do that here. This is a free function. You have to do a lot more manually. Yeah, I'm starting to yawn. Can you imagine? What I should have done. Okay. Is this right? Okay, and then all of those are by value, so we're going to use the copy constructor again, and then we implement this in terms of the base class. Also all of them. Operator star length v2. And that's it. I think all of those work like that. This would be point comma v2. Plus and again point v2 with a minus. And this is again a point, a v1 I mean. And then we have the next one, namely point itself. There was no rectangle, I don't have anything else. This is the last one. Oh, I should create a direction. It would be nice to have direction. Constructors. Maybe we should not do this. Adding here certain constructors, the other constructors I don't want anymore. Explicitly don't want them. I need to add direction. Yep, let's copy all the constructors. Although I just did those two. We don't have a line piece, it is dubious. And I don't have a direction. It's so annoying. Yeah, it's almost silly to use the base class for that. I don't want to be consistent, so I'm going to do that. And the optimizer is going to short circuit that all the way anyway. That's what I trust. Otherwise I would not do this. Speed before anything. And that should be using copy constructor of point if it has it. So we have a source point, and that has an, oh, we only have a default constructor or constructed from XY. I cannot construct it from Cairo inner point. Maybe that does make sense. I don't dare to change that, to be honest. Yeah, I should not change that. Definitely not change that. That makes immediately all the other things, well, all the other, the vector also dubious. Allowing to do that is, oh, I can make it private now. Yay! So in the vector anyway. Let's not add it here. So really can only construct it from X and Y values. So I just should do this then. And yeah, currently, so all of these things are returning, well, this one anyway, it returns Cairo window vector here. And I want that to be converted to the current one. So we need a constructor then for it. But I don't want to have a public constructor for that, because then you can pass immediately every vector of any coordinate system, because they are derived from Cairo window vector. So then you can pass that to that constructor. But you can add a vector to that const reference base class base copy constructor. I have the feeling that I'm missing my own copy constructor now. And if I can add one, but if I do that, don't you have a problem then that it is ambiguous with this one? I guess only if you try to pass something derived from it. I don't think explicit helps with that. Therefore, I was thinking maybe I can put explicit in front of it and then remove the const reference, which then would cause us to construct make a copy, but we do that anyway, right? I think copy elation would apply then, so we could have still one copy. I think that this returns a Cairo window vector, aka the base class, by value. And maybe we'd have to move it. It is a temporary. All of these are temporaries. well, apart from the cost. But well, the 4 that returns it by value. So we could use an R value reference instead of copy constructor. And then you probably still have the same problem if I would want to add a R value reference copy constructor, but a move constructor does. However, there's no reason to add a move constructor. I can do without it because yeah, this thing does not have any internal memory allocation. So it's a bit of a trick, I think, but let's do that. So this works because these things return stuff by as temporaries, and then we use the copy constructor. I mean, this turns into an L value reference, or where this is. I doubt I even have a move constructor. Like I said, this is nonsense. So no standard move around the base here. I just use it. Use the copy constructor of the base class. And that means that it will copy, but then the result is constructed on the stack in the place of the return value here. So there's copy elation there. It's not copied again. It's not copied twice, say from the base class vector to the temporary and then again to the return value. That doesn't happen. But yeah, I think that I do need a copy constructor here. So let's add our own copy constructor. Yeah, I already copied these, so that was all the point. I think I have a complete class now. Minus all the compile errors that we all get, but it's a good first attempt. Did I already add a vector somewhere? Probably not. So as we're working on this. And do you have a point here? And I want to add a direction. Let's just continue here. Yeah, no, we don't want to do all those lines. Okay, so I could add a vector here, although I would also be very happy with a direction immediately, but don't have that yet. So let's start with the attempt to create a vector. Actually that one first. Well, yeah. Let's add a vector CS. And we want that one to be, call it the axis direction. And I have to do again something like this. Very, very, very much the same actually. Could use the same point, but does this work? I'm afraid if you transform a vector, is it going to move the origin of the vector as well? Or does it just move the origin to the origin of the new coordinate system? I have the feeling I need a line point rather, or actually I need to arg. So I did all this work for nothing. A direction might have worked, because in the case of a direction I know it is a direction, and then I can just apply the rotation. Yeah. Oh, I should have used a size. That did work. Size also, if you transform a size, also only the rotation is applied. No, actually the rotation is ignored. Only the scale is applied in that case. And for a direction, we want to ignore the scale and only apply the rotation. So yeah, I would have needed a direction, I think. A vector won't work because it's kind of treated like a point as well. But I want to see if this compiles, because, well, you never know, maybe in the future I need a vector. So yeah, it doesn't really matter, I guess, what I use here. Could use the same point. I don't think I can pass that, and I just have to pass the point itself. So that would be a vector that obviously points from the origin to that point, which is then in positive or negative direction, and sometimes even 0. But that's not what you want. No. So I don't want to use. I want to use a point that is. I have to pass a point here. That point must be the same as this, but then not use a value, but use 1. So that's now 0, 1 or 1, 0. And then we can use that as the only point or to construct a vector. But it doesn't make any sense because, well, okay. a delete is coming up. Let's try to compile this. I thought, oh, no errors, but I didn't even include a header that that you just wrote. Loads and loads of errors coming up. Yeah, we don't have a direction, that is true. I could use Cairo window direction for now. Or just leave it out completely. Yeah. There is no Cairo in the direction, probably because it didn't include a header. Yeah, Cairo in the direction is just math direction. Line base, the same thing. No member named operator star in Cairo window vector. It's a free function, so it's not like that. It's not a member vector. Oh. Oh, it's in math. I put them in math. Obviously, I put them in math. Yeah, the math vector here, we are inside the namespace math. Excuse me, what did I just do? Well, it compiles. So the trick with the constructors worked apparently. Yeah, maybe you should add a direction. I mean, yeah. kind of have the same problem then, right? So just a lot of stuff that all needs to be copied and casted. Very, very annoying. If only we had an AI that I could just order to write that. And then not waste 2 hours with fixing it afterwards. Shall I do it? Just a lot of work. Just no, I'm not gonna do it. I'm doing it a little dirty way. Let's create an origin. I think the default constructed point is the origin. Yep. So this is the origin. No, this is going to be the same as for both axes, obviously, for every k value even. Put the origin here. Which means that we also can define an origin pixels. Yeah, I did that before, and I think then I put the CS in front of it, right? So it's like something with origin, capital O origin, I think. TSX origin CS origin. I think I have a CS origin CS. Yeah, this. Let's define it like that. I already have that defined in coordinate system.h. It's a sad, sad world. I have to do it again. My God, even this. Yeah, oh no, you're not entirely like that. I do need this one though. What? Origin pixels. Da-da, da-da. It's a member. We already have it. Yippee. Good thing I saw that. Ugh. Huh? This is a different window or something. Oh yeah, it is. Let's leave that. So we already have this. It's called CS origin in pixels. So after converting the tick mark to pixels, you have a vector. You can create a vector that points along the x-axis or the y-axis. So make a point. No, I want to make a direction. Direction, but this must then be a math direction. Sorry, where did I do that? using. Okay, so we have a direction inside the coordinate system already. Direction can be constructed from a line, but hopefully also from something else. Moth direction point, yeah, single point. If the only point is given, the direction is from the origin to that point. But that would be the pixel or origin, so no. I need 2 points here, from to. So I can pass the origin and then the 2 points. And then it's gonna make it wait a minute, why am I using this? Something, hip something, hypotenusa, I guess. That calculates the length of a vector. Yeah, length. I guess I have to use it here then. Okay, so this direction is pointing, and the must be point in the stupid music positive x direction, or y axis direction then, from the origin to something positive. And the only thing I have is tick pixels. But that might not be the positive direction. Certainly not when k is 0. Suppose we just don't draw tick mark when k is 0. And then here we can do, if k is larger than 0, then we use tick pixels. Otherwise we have to use minus tick pixels. This is then a unit vector pointing into the positive direction of axis. Okay, and then I need to rotate that, I guess. Or shall we first make it a tick mark thing and then do an cross product or something? Not sure I can rotate directions. Okay, oh, we can get the normal. That's as good. Actually, it is the normal inverse. Or I want to, let's say, the positive y-axis, I want to have something that points in the negative x direction. For the positive x direction, we want to point in the negative y direction. That is again an opposite inverse. So either I have to call this or that, depending on the axis. And normal means rotate 90 degrees. So in this case that would be, I think like that. That's the normal. And the other one is the normal inverse. And then it will look different because the y-axis points down in our case, but yeah, it can't be helped, I said. It's still the best thing to do. Turns by value. Let's make a new direction. X is normal. Yeah, not really normal then, right? It's the tick mark direction. Jesus, I call it a tick mark. And it's always in pixels. And then again, it depends on which axis it is. So if this is the normal axis, if this is the x-axis, then we need to rotate that thing, taking the normal. And otherwise, we take the normal inverse. And then I need to find the end point, right? Let's say, well, there's going to be a point in pixels again. So let's call this tick end or something in pixels. Which is that is then this plus the length. Well, let's use 5 pixels, 10 pixels. So 10 was a bit much. I think 5. 10 times the direction. Now, hopefully that compiles. Can I multiply a direction with a scale, and if so, what do we get? And that means go to math. Nope. So it doesn't make any sense. So I have to create a vector first, I think. Create a vector from the direction. And then multiply it by 5. I'm gonna use this. I'll get an parcel length immediately. That's even better than. And then we draw only a single line. And well, from tick pixels to the endpoint. What happened? Tick end. Here also tick end. This can be just axis style, no reason to make it blue. No unary expression for minus tick pixels. Well, then I bake it into this, because this is already inversing it. So you have to inverse it again if k is less than. So instead of, let's say, I could create an axis pixels from. Oh, this is a direction. So I simply do always that. And I have to invert it again if this is what was it? If k is negative. Did I now invert it too much? Let's say if k is positive, then this is false. If true is unequal false, oh, that would be false. So we are inverting this now. So just use equal then. Now what? No viable conversion from point to point pixels. Oh, because I'm adding a math vector now. Well, good thing I added the vector then. We actually use it. Oops. Pixels. Right. Yeah, yeah, that's right. I mean, this is a free function and we can't convert like that. I mean, I really have to do a cast here. I can't cast it even. Huh? What? I can cast it if I know for sure that my point is source point, right? Source, source point. To this, my point is derived from create point, which is a math point, and we do not add any members. So that's why you can even cast it by value. Theoretically, I would have to ask, add a static cast that checks that the size is equal. Or make it even more secure. This is, yeah, I have I think did you lose the compilation now or not? I think we did. Well, that's too bad then. I'm getting sick of it. So this thing now returns a temporary, and then we cast it to the type that we want by const reference, which is allowed on a temporary. And then we have a const reference to a temporary, which I don't know what happens then. It's gonna copy it or not copy it. You have to do the same thing here, right? It's also a point. These are vectors that should work. Yeah, or I could add a public move constructor for the point. That kind of should work as well, but normally we don't have any R references. The vector is currently private, but that's because this is the only class currently that is adding the coordinate system template parameter. I'm going to do that. The class is just too dirty. But it will have to be public. But okay, so the point here is that... No, it's not. This point here is... source point. Can allow... Yeah, no, I can't do that. Damn it. Then it's gonna convert any arbitrary temporary to... I mean, it's totally going to mess up my coordinate system type safety. And even then it's not really type safe. But at least... Yeah, I don't know. It's not... I don't like it. But, well... Now it compiles. Okay, so we're going to run this again and then see that it works. And then I think I'll go for a walk. Oh, I don't have dinner in the house. I'm gonna walk to the shop to buy me dinner. It sort of works, yeah? And except that it doesn't because the tick marks point in the same direction. Well, that's what I wanted. No, it's not what I want. That is so confusing. Damn it. I want these to point like that, and these to point like that. Oh, they do point to the same direction. They point in the same direction when it is the negative quadrant. So is this a negative quadrant? Yes, it is actually. This is the positive quadrant. That's why the rectangle is in. So the whole rotation makes it annoying anyway. The but even without rotation, I think it's still looking a bit weird, because the y-axis is upside down, right? So yeah, let's see how it looks like without any rotation. I think it's still looking weird then. So yeah, it's horizontally or mirrored in the horizontal line. So the x-axis sticks point upwards, because this is a negative y and this is a positive y. But if I add values, then you'll see that this is the negative y. This will have negative values, and then here the positive values. So the whole thing is just upside down. But yeah, do we want that, you know? Maybe I should work with, no, well, we want that, because that's how Qt is working. Normally I would just invert it again, and then only invert it at the moment that we go to pixels. But yeah, I think this is good. Yeah, we have tick marks. Well, Geisha Nix is adding the labels, the actual values that go with the tick marks. If I keep this up, though, I'll get the x-axis labels upside down. It's just, it's a bit too much. Or is it? Shall I just put them upside down, period? I mean, come on. Or shall I rotate them to be correct for the... So I want them to appear here, but then rotate them so they are readable. So up for in the pixel coordinate system. And for example, in a case like this, I used to have an anchor point here, like 10 pixels out. And then we have a rectangle here, and that rectangle then contains the text of the label. Now imagine this thing is rotated. Should the rectangle rotate along with it, or should I keep it horizontal? So let's rotate it 45 degrees. You could put the text level here, or I can put it like that. If I do that, and if you keep rotating it, at some point it's going to be here instead of here, centered like that. Yeah, maybe just switch exactly at 45 degrees. So in this case, we could put it like this or like this. And if you rotate it even further, then it's going to be like this until it becomes flat even. So a line that is horizontal all the way up till here and all the way up till there would have it along the axis, I think. Yeah. And then vertical line all the way up till there and there would have it like this. So here and here. Well, rotate it the other way around. Make it. I could also put it like that, of course. I mean, it's like this. If you rotate it a little bit, so just like that, like that, like that. And then if you rotate it even further, then rotate the level 90 degrees. So it becomes horizontal. So not like this. In this case, it will be either like that or like that, along the axis or perpendicular to it. I just don't want it to get upside down, so we do rotate it every now and then. So then here it is horizontally like this, and then it rotates like that, and then if we reach this, it's no longer like that, but it switches to this, and then you can read it again from here. It's 45 degrees. Now if you continue rotating, then it's again readable as normal. And that continues like here, readable as normal, and then we switch here to, I guess, like that, and it becomes readable again. Yeah, I think that's the plan. It's a good plan. But easy is different, because I have this code. Damn it! I wrote this code for Cairo window. Though I didn't, because I wrote it for axes that are not rotated. And I have to really redo that code, because now the axis is rotated. Highly, highly annoying. It doesn't do that. Yeah, there's no redraw, I guess. So why is there no redraw? That's a good question. Shouldn't it redraw stuff? Well, it's a resize, right? I mean, if I put another window over it, it would let me put another window over. Why is that? Why? Oh, this is a dock. Oh, okay. So I'll make this one normal. Make a smaller window. I'm not sure if this is being redrawn or not. It's probably just the window manager doing stuff. I don't know. It's just a window manager, I think. We would get debug output. We can know for sure. We just turn on Cairo window debug output. So don't see the mouse. Well, probably a different debug channel. So what happens if we do this? Absolutely nothing. I think it's not even notified. Nothing. Nothing, nothing, nothing. Nope. I just pressed Alt. What the hell happened there? It just destroyed my window. Must have seen some key. And thought, oh, you press a key. Let's terminate the program. Yep, let's go buy dinner. Dinner for Carl. I'll be back later, most likely.